Alright, first one, how to distinguish between population and a sample. Gotta be able to pick out, guarantee there's problems on the test, gonna say, is this a population or is this a sample? What is the population here, what is the sample, or something along those lines? What's the difference between a population and a sample?
Population is everywhere, sample is what you selected.
Population's everything, sample is, give me something,
What you selected.
yeah, sort of, but give me something that.
Piece of a population.
Exactly, part, piece, I'm gonna put part because I don't wanna spell piece wrong. Part of population. How to distinguish between a parameter and a statistic. Parameter goes with what? Population, good. Statistic goes with sample. Gotta be careful when you're dealing with populations and samples. Gotta be real careful, because if I say let's see, what's a good one here? All pharmacists at CVS and Eaton were surveyed. Am I dealing with a population or a sample?
Population.
The population. Because I'm just dealing with those certain pharmacists at that. So you gotta be careful, because sometimes it seems like it's a sample because it's so small, but it's actually a population because that's all we wanted to deal with. When I surveyed you guys, if I wanted to just deal with, if I said the prob stats class at National Trail High School was surveyed, am I doing a population or a sample? Are you guys a population or a sample? Population.
How?
Alright, because I'm just dealing with your class. I don't care about everybody else. Alright, now if I say, I surveyed you guys and used you as a sample of the entire population of National Trail, then you would be a sample. So you gotta be careful, because sometimes, you know, the same group could be a sample, it could be a population, depending on what you're trying to deal with. How to distinguish between descriptive statistics and inferential. What's descriptive do? What's a descriptive statistic? Okay, it describes whatever's going on. It describes whatever's going on. What's an inferential statistic? Yeah, we'll go back. What's inferential? Okay. Now, a guess, I'm gonna write this down, and this is horrible, but hopefully because it's not really a guess, alright? It's, and make sure, Sean, you run down and tell Mr. Bryan or Mr. Swihart, hey, we were talking about educated guesses in math class today. You know what they'll tell you? There's no such thing. If you're educated, you don't guess. Alright? There's no such thing as an educated guess.
Well, I guess you'll look fine, so I must not be educated.
I'm recording this, Jesse, so I'm not gonna comment on that comment. Could get me in trouble. Maybe you'll learn something here. They'll put stuff on video
So I
or
say stupid things you can't
anything
respond to.
that you don't want somebody else to hear.
I didn't know you were.
Yeah, but no one else would hear it
No,
except
they're-
our class.
Who knows?
So the only problem is that's
I know, but this gets right on Moodle and anybody can get to it on Moodle.
Just let's be honest.
Maybe Jesse's mom, because Jesse goes home.
When I go home, the last thing I talk about is school.
So on this, and inferential, it's when you sort of make a prediction, or you say, hey, we think this is gonna happen based on the data that you collected from whatever sample or whatever you did. No, it's not really a guess.
I forget what they are.
Alright, so descriptive. If we're doing a descriptive statistic, something that describes the group, alright? There's 14 of you, or no, there's not 14 of you. What is there? 11 people in class today. Alright, that's sort of a descriptive statistic. That's all descriptive is, or might be the fact a descriptive statistic could be hair color. That describes that certain whatever. And then an inferential statistic is where I say, that's where we go back to the insurance. And we say from ages 16 to 20, we expect are gonna have about 1.3 wrecks in a year. We don't know that for sure. We don't know that everybody 16 to 20 is gonna, but we're making an inference. We're sort of making a prediction of what's gonna happen in that age group. Does that make sense? So inferential is what we do. Descriptive is what we actually see. I seen that there was 11 of you in here today because I counted. All right, that's a descriptive. I know that that's a fact. Inferential is from that, I'm going to make an inference that every Monday we're going to have 2 or 3 or 4 people absent. Now, is that always going to be right? No. Does that make sense then? Did you guys want me to go back and do something with each one of these? You understand the others? All right, qualitative data and quantitative data. Now, where I get confused a lot, and maybe this is part of what's confusing you, I'll flip it back here in a second. You got descriptive and inferential statistics, and then we jumped right to qualitative and quantitative data. Two sort of completely different things, all right? Don't think that one's splitting up the other group. All right, qualitative data. What's qualitative data tell us?
Quality.
Some kind of quality, all right? Just some kind of quality in the item. Give me an example. We just said one a second ago. That's a quality, all right? But if we were doing some kind of survey or something, what might it be? Because we're probably not going to survey the ceiling. Hair color, eye color, shoe size, height, weight could be, all those could be some kind of quality. Quantitative, what's quantitative data?
Quantity.
Some kind of quantity, usually deals with what?
Numbers.
A number, some kind of number. Now, you talk about something I said weight a second ago. Could weight sort of be either one? Yeah, sort of, right? If you say Eversole's about 40 pounds overweight, then that's sort of like a quality. But if I say my weight is, and give my weight, then we might be talking about a quantity. Qualitative, quantitative, be able to distinguish between those two. Be able to classify data into 4 different levels of measurement. Nominal, what was nominal? Okay, and it's probably what? Probably just, probably just names, it's some kind of quality, right? Alright, so, and I'm just trying to get one word here that'll help you sort of, know what we're saying. Nominal would be like National Trail High School, Preble Shawnee High School, Twin Valley South High School, so on and so on. We're just listing them. Ordinal means you're putting them in some kind of order, but can you always do a whole lot with that order? No, just because Sean is number 1 on in my grade book, does that really mean anything? No, I'm just listing you guys in some kind of order. It does mean something, Sean. It means you're number 1. Interval. What was interval? So if you got your books open there, flip to, what was that? That was section 1, 2. There. So they can what?
Range and order in the difference between data entries can be calculated.
Alright, so there is, this time it does matter when you put them in order, right? When you're doing an interval, it makes a difference. Hey, you can do something with it. I put this at number 1, this at number 2, this at number 3. We can say that the number 3 spot is 2 spaces below the number 1 spot, or something like that. We can actually do something with it. So it's still in an order, but you can actually do some calculations with it. You can actually do something with it. It actually means something. That order tells you something. Putting college football is getting ready to start. Putting the college football teams ranked from number 1 through number 20. Is that an ordinal? No, because it actually means something, doesn't it? So, it's a interval. You guys can't count past 20 because that's all the fingers and toes you got, so that's why I didn't go to 25. Ratio.
I'm actually missing a toe.
Are you? Missing some brain cells too. Ratio.
So you're gonna say that when you're close.
I tried to say it low so catch it. Ratio, what's a ratio?
2 data values can be formed, so one data value can be expressed as a ratio.
So, what is a ratio then?
I don't think it's something.
Something like 5 out of 7, right? That's a ratio. So what you're saying is, when you have these, whatever it is that we're comparing or looking at, when we collect our data, you can actually take these two and say, let's say if I make up a set of data here, and we got cats, dogs, pigs, and I give them some kind of number or something that we're collecting data about. Cats is 12, dogs is 7, pigs is 6, we can actually compare these and say whatever that data is that we collected, what do we notice about cats compared to pigs? There's twice, it's twice as much. All right, so that's what a ratio is. We can actually say something like it's twice as much, or it's half as much, or it's 1.5 times more than the other, or something like that. We can actually put the two numbers and divide them together. With the interval, probably the main thing that we can do is subtract. We can say in the preseason AP poll, Florida State is ranked 4 spaces higher than Ohio State, or something like that. We can't say Florida State is 4 times better than Ohio State because of their rankings. Okay? But with ratio, we can say that. We can say, hey, this one has 4 times as much. So you can do more calculations with it. You can set up a ratio. So maybe just a fraction bar there, something like 5/7 or whatever. You can change it to a decimal and show that, hey, this one is has half what this other statistic has. As we're going through, since this is a math class, which of those 4 levels do you think we're going to deal with the most? Ratio, because we can actually do more math with it. All right, so we're gonna be more on this end of those measures because we want to do the math. All right, how you collect data? Different ways to collect data. Observational study. Guarantee there's on this test. Seems like I remember. I know it's been a while since I ran it off last week sometime. But it seems like there's like 5 or 6 questions that just say, tell what kind of study this is, whether it's observational, experimental, simulation, or a survey. And you gotta just write which one it is in the blank. All right? What's an observational study? You're actually watching something, right? Again, I always think of the Jane Goodall or whatever her name was that went to wherever and lived with the monkeys. She was observing them, the apes or whatever. I don't even know if that's the right name. Is that right? Jane Goodall, is that right? The idea you'll never see stuff.
Never heard of it.
An experiment, what would an experiment be? Okay, so you could run like an experiment where if I'm trying to see if a drug helps to help people lose weight, and I could sample my drug. Now the bad thing with sampling stuff like that is what happens? Can you just sample whatever you want? Nah. People could get hurt and then you could get in trouble. And that's why a lot of these things actually pay people to come in, and then you gotta sign a waiver saying, if something happens to you, we are not liable. So it's some kind of experiment. Simulation, what would a simulation be? Experiment, I didn't write anything down for experiment just because that's sort of self-explanatory, right? You do some kind of experiment on whatever to see if something's. What would a simulation be? Right, it's sort of like something fake, something where you set up something, you stage something to see how people are going to react to it. Right. They I was watching the news yesterday, and some of our army that's somewhere, I can't remember where they said they were, they're over in Afghanistan or somewhere. They were actually, and I'm thinking, man, that's not good. Because they were actually doing simulations with IEDs. And there's a armored vehicle going down through there. You know, they got their troops doing what they would normally do if they were going into battle. And there's an armored vehicle going down, right down this path. And right next to it, a bomb actually blows up, and it was a big bomb, an actual IED. And I'm thinking, that was awful close, because it was like this far, and you could see the car shook and everything when it blew up. But they're just running simulations. I'm thinking, that's a little too realistic. I don't know that I want to, but they're trying to make it as realistic as possible, because they've got so many people who are out there not used to it, and you know, and they're walking down the road, and all of a sudden they're gone because some IED that somebody set up alongside the road or something. So they were making it realistic, and they actually had, I mean, they had planes coming in and dropping bombs. I'm thinking, you know, the bombs were maybe 100 feet, 200 feet away from the troops as they were walking. Those bombs aren't, when you're dropping something, that's not a exact science. I don't know that I'd want to be that troop on the ground that's having John up there, who maybe he's having a bad day and pushes the button a second too early to drop this bomb. But they were actually doing these simulations. I guess you got to trust each other. What's the survey? Okay, you ask questions. Maybe you're just sending around a piece of paper and saying, hey, fill this out. Asking questions of the certain sample or population that you want to deal with. Know how to design an experiment. Somebody help me out in your book. Flip to find where it says how to design an experiment, because it's got like steps. And we'll write the steps in here for you. What's the first step on this designing an experiment? Got your book right there too. Nick's already got his book open to the page that he doesn't want to help us.
Discuss how to design this study. I don't know if I'm on the right page or not. It says experimental design.
All right. We went to steps. How do we design the experiment? We had
Identify the variables.
so identify, and I'm not going to put variable. Identify what looking for. All right. So you want to identify, hey, what are we trying to do here? What am I trying to get to? You know, what am I trying to decide? What do we do after that?
Develop a detailed plan.
So we want to develop a plan. How are we going to figure out what we're looking for? If I want to figure out what kind of cars students at National Trail Drive Am I probably gonna sit in here and just guess? No, what would I probably do? Go out to the parking lot maybe. Go to football games, go to other sporting events, try to collect data that way, right? But you gotta develop some kind of plan, how am I gonna do this? And not only go to these different things, but do, as I'm developing my plan, I probably wanna put a little more into that because I don't wanna see Sean, he's driving this car and then go watch somewhere else and write him down again and again and again and again, right? I don't wanna collect the same data over and over again. What's the third thing say? Collect data. What's the fourth thing? Describe it. So you collect it, then you describe what all that means. I collected all this data, you know, group it up. Okay, I seen that there was this many driving Chevys, this many driving, so on and so on. Get it grouped together somehow and describe what it means. And what's the last step?
There's actually 2 more
Oh,
steps.
is there 2 more? What's one after describe?
Intercept, interpret.
Oh, interpret.
I wrote it down.
So I was thinking that those 2 went together. So you describe the data. Describe must just mean, you know, get it all grouped together. Then interpret it. What does it all mean? What's that telling us? And then what's the last thing? So this one said interpret, you sure?
Yeah, it says
Interpret
interpret.
data to make decisions about the population using differential statistics.
So make inferences. On this one's where we would make inferences, right? Interpret, make some kind of inference that, hey, most people drive this kind of car. And what's the last one? Look for errors. When we're talking about errors, it could be like a bias. You know, what is there some kind of bias? When I worked at the other school that I worked at, a whole bunch of the parents worked at GM at that point. Would there be a bias for what kind of cars those kids drove to school? Yeah, because their parents got deals through GM. You get like 25% off or something if you work at GM. So when they're buying cars, they're buying GM cars.
I'm still blackboard.
How to create a sample using random sampling, simple sampling, random sampling, stratified, cluster, systematic. Did I forget it on here too? I did, didn't I? How come I didn't put it on here? What's the one I'm missing? Convenience. I don't really care about the difference between random sampling and simple random sampling. We're gonna treat them sort of the same all the way through this class. We're not gonna go into that much detail where we need to know the difference between those two. What is a random sample? How could we come up with a random sample? What has to happen in a random sample?
Has to be like a chance for the whole population.
Right, everybody's gotta have the same chance of getting picked. Sort of really, really hard to get a random sample. Because used to be when they tried to get a random sample, they would use telephones. And they would just pick people's name out of the phone book. Well, did everybody have the same chance of getting picked? No, because at that point some people didn't have phones, some people had unlisted numbers that weren't in the phone books. So those people didn't have the same chance as everybody else of getting picked. The only way that you can really do a random sample is if you got every single person's name or whatever you're trying to deal with, you put all their names in a hat and draw from there, and that makes it so that's sort of difficult to do. What's a stratified sample? Flip back to the pages again. What was stratified? That's what we just got done covering on this assignment.
Members from each segment of a population. This ensures that each segment from the population is represented.
Alright, you know what that means? So with stratified, what you want to do, if I was going to do National Trail, how would I do a stratified? What would I have to make sure that I have? Can I just go out and pick people and it's not going to work that way, right? What is the school split up into?
That's grades.
Grades. So be like freshmen, sophomores, juniors, seniors. So we make sure that we pick, for stratified, we make sure that we pick some from this group, some from this group, some from this group, some from that group. That's what stratified is. Making sure that each group is represented. Now you might even go a little farther than that, because if I just pick John and Joe from the freshman class, what's wrong with that?
There's not as many.
There's not a girl in there. You might want a female in there to make sure that it's a good stratified sample. How about a cluster sample? What would that be? How could we come up with an example of a cluster sample?
Has members from randomly selected segments of a population.
So what if we were gonna do the school here? How could we do that right now, right this moment?
Pick random people.
Would we just pick for cluster, we'd just pick random? How could we do a cluster? Classrooms, certain classrooms. Maybe we pick room 208, room 212, room 215, room 217, and we just pick certain classrooms. So certain clusters, certain what? Groups, certain parts maybe. You pick certain areas. A lot of times with cluster, you'll see something like this. They'll split something up. Maybe they split up New Paris into all the blocks, and then they just pick this cluster, that cluster, that cluster, that cluster, and they survey those certain areas maybe. About systematic, what's systematic?
Like every fifth or every tenth.
Right. And if you write that, systematic's probably the easiest one to see what it is, because anytime you see every fifth or every third or something like that, then it's systematic. So I'm just gonna write every fifth. That's an example. When you see something like that, that's a systematic sample. Convenience. This book left out convenience. Did they sort of leave it out too?
It's sort of just like, it's like 2 sentences.
Yeah, they sort of, because they didn't like it. It's why? Because is a convenient sample a good thing? No, it just means, hey, you guys were convenient for me, so I sampled you, and I didn't really put a whole lot of thought into it. You see a lot of convenient samples, and they don't really want you to know this, but you see a lot of convenient samples with sampling for the presidential stuff. All right? You think every day somehow they're getting a new sample. Oh, now Hillary's up by 7 percentage points. Oh, then tomorrow she'll only be up by 4 percentage points. You think, how do they figure out all this stuff that quick and get it calculated? Well, it's because it's convenient. They go out and stand on the street corner and go, who you gonna vote for?
And we have a group of
Who you gonna vote for? Who you gonna vote for? Right, and if there's about 10 of you walking together and you're all same kind of people, then you're probably gonna vote for the same person, right? So, one day Hillary's leading by, and it was really bad when they were doing the primaries and everything, because one day Trump was leading, you know, Kasich and all the rest of them by 10 points. The next day, Kasich's up on Trump by 5 points, and you think, well, what's going on here? And it's because they were doing that kind of sample where it could switch every day. So convenience, all convenience is whatever's easy. Whatever's available. That's what convenient is.
Is this the last one?
I think it was, I'm not sure. How to identify a bias sample? What does bias mean?
That you're,
You only vote by you only certain
Sorta, what it do? It's unfair. It's messed up, right? Something's wrong with the sample to make it so it's not really true.
Like, the school with the people, they work at GM.
Right, so something like that, that would make it biased, because when I worked over there at Jefferson and all their parents worked at GM, well, most all of them drove GM cars because they got a better deal on them. When I surveyed you guys and asked if you took probability and statistics, there's a bias here because you're sitting in here in the class right then. All right. So be able to identify a bias, be able to, and those aren't the only things, you know, you gotta be able to use your brain a little bit, and there's gonna be questions like this all year long on tests, where I'm gonna ask you, give me a reason why this might not be right. And you've got to actually come up with something. Now, when Jesse writes something down, and it's something completely and totally that I don't agree with, am I gonna write on there, Jesse, this is the dumbest thing I've ever heard. This is completely and totally wrong? Probably not. I mean, if we're doing some kind of survey, and that survey is about what to do for the cafeteria food, and Jesse comes up with this crazy idea of what to do, well, can I mark it wrong just because I thought his idea was crazy? No. Did he do what I asked him to do, was come up with an idea? Yeah. So make sure when you're answering these questions on these tests, you're answering them, because a lot of times I'll read through it and Jacob in there will give me some answer and I'll think, what? But hey, if that's, you know, what his thought process was, then hey, not everybody's got to think the same way, right? Yep, that was the last one, Jesse. All right, your assignment's on page 29, 1 through 38. We got about 20 minutes, about 16 minutes, I guess. If you wanted to get started, I'll give you about 10 minutes, and then I'll probably come up here and work some problems if you want. All right, problems you want to see worked real quick. Question. Maybe you just want to see the answer. No. And I will come look at your paper, and if you've got nothing written down, then I'm not doing it for you.
Okay.
So those of you who actually have been working, if you wanted me to, like, give you, you know, say, hey, is this right? Then I'll do it for you.
All number 5, so you want to do 5
Number 5. Determine whether numerical value describes a parameter or a statistic. Remember, parameters go with what? Population. Statistic goes with sample. 2019 payroll, the Philadelphia Phillies was $113,004,046. Is that a parameter or statistic?
population.
Is it a population? What are we dealing with? The whole team. So apparently that would be a parameter. Even though it's just the Phillies, It didn't say anything about all of Major League Baseball or anything like that, right? So we're just dealing with the Phillies. Yeah.
So this is actually a serious question. Why is a what is it? Is that what-
Parameter.
Yeah, it's statistics. What does that have to do with population sample?
Parameter, you're thinking this. You got this word, statistics. That's all the math that we're dealing with, all right? Statistics is the name of this subject. A statistic is a certain piece of data. All right? Parameters talk about, it's a certain piece of data, but it talks about the entire population. So, all of the Philadelphia Phillies, all right? That's what they made. If we were just talking, let's say, we were talking about Major League Baseball, and we gave the same stat there for the Phillies payroll being $113 million, then that would be a statistic because it's dealing with a certain sample, just the Phillies. But since we're just talking about the Phillies, they're our population, so it's a parameter. Parameter is a piece of data that goes with the population. Statistic is a piece of data that goes with the sample.
So that's like the data.
Right.
Okay.
This is a parameter is a piece of data. Statistic is a piece of data. The one goes with the sample, one goes with population.
Number 12.
Number 12.
I actually got that one. Like, that's one of the ones that it could be either or.
Determine which data are qualitative data and which are quantitative data. Number 12. Social Security numbers of the employees at an accounting firm.
Because it's talking about a lot of them, but it's your social security.
But
That's
qualitative or quantitative?
quantitative.
Quant, N or L?
Yeah. That's the.
It's qualitative. You don't,
That's what I want.
because your social security number, you don't have a social, whatever your social security number is, isn't for any reason other than it's just a identification number. So it's not like if I get out my social security number and I compare it to yours and I say, I'm a whole lot better than you because my number is this. It doesn't work that way. So it's just a quality.
So the zip codes one that's on there too would be the same thing.
Right, that's just a quality, it's just certain areas, there's not, you know, unless you listen to rap music and then they say, 319, that's where it's at, and they think it's better or something, that way.
319. 420.
420,
That's what they want.
so you,
That's what they want.
that goes right back to the brain cells thing that we were talking about a while ago, Jesse. Everything comes full circle in here. You sort of explain it all. I know, so this time though, when Jesse says, you know, his mom and dad's in here, I'll say, oh, hold on, let's listen to this. Your son mentioned 420. Boy, I would hope that my son didn't know what that meant.
It's all
Oh,
over
your son does.
Instagram. Whenever it is 420, it's all over Instagram.
Your son's experience.
I don't know.
Hey, don't.
Is it just a number?
Shut up.
I put $5 and you extra